Hello viewers, have a good day. Welcome to another tutorial. In this tutorial, we will learn how to calculate land surface temperature in ArcGIS. Land surface temperature of Landsat 9 or Landsat 8 satellite in ArcGIS. So this is a Landsat 9 satellite, that means latest Landsat 9 satellite image, and we'll learn how to calculate land surface temperature for this Landsat image. But I have already uploaded another tutorial, that is how to calculate land surface temperature for Landsat 5 and 7, because Landsat 5 and Landsat 7 has different calculation or formula for the preparation of land surface temperature. So you may see the previous tutorial for the land surface temperature of Landsat 7 and Landsat 5 satellite image. So in this tutorial we will learn how to prepare land surface temperature for the Landsat 8 and 9. So you can see here, this is the some important note that you should write in your copy, because land surface temperature calculation is a quite long process, but this is very simple or easy if you understand that. So you should copy this. Okay, it will help you to preparation or calculation of land surface temperature. So there is a total 6 steps. One is top of the atmosphere, second is brightness temperature, third one is the NDVI calculation, fourth one is the proportion of vegetation, sixth one is the radiance emitting, and sixth one is the LST calculation. Okay, and here I will explain one by one briefly during the calculation. Okay, so here you can see here band 4, band 5 and band 10. Band 10 is a thermal band, so we'll do land surface temperature on the basis of this band 10, and band 4 and band 5 require for the calculation of NDVI and proportion of vegetation. Okay, so before going to start, you should see or you should open your MTL file for this Landsat image. So within this folder you can see here that.mtl. So this is the MTL file, and within this MTL file there is a number of information is available, and this information is required for the calculation of land surface temperature. Okay, so start with the map algebra. So this actually has within this spatial analysis tool, and within this map algebra raster calculator. Open this raster calculator. So go to the first step, that is the calculation of TOA, that means top of the atmosphere in spectral radiance, and formula is very simple, ml multiplied by Qcal and AL. So this ml and AL already available within this MTL file. Okay, within this MTL file. Okay, if I go below, so this is the radiance multiband. So this is the ml and this is the AL, means this is the radiance additive band. So you can see here, this is the radiance multiband 10. So this is the ml value, that is this one. And for the AL, you can see here radiance additive band, that is 10, that is 0.1140. Okay, so within this raster calculator will put all of these thing here. Okay, so again open this MTL file and go to the radiance multiband. So just select this, copy this. Okay, and open any I can say Excel file and paste it here. Okay, after that double click and the value will convert, then copy it and again come to the raster algebra, start with bracket. Okay, then paste it here. Sorry, no need to bracket, just paste it here, then multiplied by, you can see again the formula, multiplied by Qcal. Qcal means the band. So here our band is, you can see here, band 10 is the thermal band. So double click here, then click on plus, and you can see here our formula is AL. AL means, again go to the here AL means radiance additive band, that is, this is the value. So copy this. So this is the radiance additive value, that means AL value. Okay, go here, paste it here. Now go to output raster. Okay, so I will create a file, that is LST Landsat 9. Okay, so within this I will save, first one is TOA.TIFF. so extension should be TIFF. TOA means top of the atmosphere. Okay, that means top of the atmosphere spectral radiance. Okay, then click save, click OK. So it is a long process, it will take some times. So go to the second step. What is the second step? Second step is to calculation the brightness temperature. Okay, so it will actually comes under from the top of the atmosphere that I have already prepared. So K2 divided by ln K1 L1 minus 273. So all of these actually constant value. K2 also available within this MTL file. Go below, you can see here K1 constant and K2 constant. Okay, so this K1 and K2 is required for the brightness temperature measurement or calculation. Okay, so again go to here, open raster calculator, and here open bracket. Okay, so according to our formula, first one is K2. So go to your MTL file. So you can see here K2 constant for band 10. So select this, copy this, go here and paste it here. Okay, then divide. Okay, and up you can see here after divide you can say ln. Okay, so go here, you can find out, yes, this one, give one more bracket here, then again see here, this is the K1. Go to MTL file, you can see this is the K1 value, copy it, go here, paste it here, then divided by you can see here divided by L. L means top of the atmosphere, this one. So I have already prepared top of the atmosphere. Okay, so click here, select this. Okay, then plus according to our formula 1, then double bracket minus 273. Okay, I can copy this or you can write directly. Okay, so this is our formula. Then go to here, write BT, so the capital BT, that means brightness temperature dot diff. Okay, then save. Here you can see again, we can check it here, K2 divided by ln, then open bracket, then K1 divided by L, that means top of the atmosphere, bracket close, plus 1, bracket close, minus 273. Here I want to give this one. Okay, now click. Then go to the third step. So third step is the calculation of NDVI, and we know that this is very simple. Go to raster calculation. So from here find out the float. So this is float. Then we know that the formula of NDVI is near infrared minus red and near infrared plus red. So band 5 minus band 4, band 5 plus band 4. So select this band 5, near infrared minus red, then divide by float near infrared plus red. Okay, go to file extension, write ndvi.diff. Okay, save, click on OK. Go to the fourth step, and here you can see here the calculation of proportion of vegetation, PV value. Okay, so this is very simple: NDVI minus NDVI minimum divided by NDVI max minus NDVI minimum. So this NDVI minimum and maximum value will get after the preparation of NDVI map. Okay, so go to main menu. You can see here this is the NDVI. If I click here, go to properties, click on source. If I go below, you can see here the statistics within the statistics, minimum value as well as the maximum value. Maximum value. You can also see this here. This is the minimum value. This is the maximum value. Okay. So go to again raster calculator. Close it. Raster calculator. Here search the square. Okay. Square. Then add one more bracket here. First one, select the NDVI. So NDVI minus NDVI minimum. So where is minimum? If I go properties, go below. So this is the minimum value. Copy this, paste it here. Then bracket complete, bracket already completed, divide by NDVI minimum, NDVI maximum. You can see here NDVI maximum minus NDVI minimum. So I can go to here, go below. NDVI maximum is this one, copy this, paste it here, minus NDVI minimum is this one, so copy it, paste it here, close the bracket. But the thing is that you can see here is double minus, here is also double minus. According to our equation, this should be NDVI minus NDVI minimum, NDVI maximum minus NDVI minimum. But our value, minimum value is minus, so that is why this minus and minus, we know that minus and minus means plus. So similarly here also minus and minus means plus. Okay, then go here, write PV. Why PV? Because this is proportion of vegetation index. Okay, so again check it, square, then double bracket, NDVI minus NDVI minimum, bracket close, divided by again bracket start, NDVI maximum minus NDVI minimum. So add one more bracket here, then click on OK. Now go to the fifth stage. So fifth stage is quite easy. Calculate the emissivity of E. This is very simple. This is a constant value, this is also constant value. We'll get PV, so we'll multiply by this value and add this value, so we'll get the emissivity. Okay, process completed. Click here, then again open the raster calculator. So you can see here, this is very simple. You can also copy this. Okay, copy this, or you can simply write. So this PV means this PV. Okay, so double click here. So 0.004 multiplied by PV this one plus this one. So these two, that means 0.004 is a constant value as well as 0.986 also constant value. Okay, then output raster. Here we can write E dot diff. This is the emissivity value. Save, click on OK. So now we can go the last step. This is the calculation of land surface temperature. This is LST. LST means BT. BT already we actually calculated in the second step. Then BT divided by 1 plus this is constant value again multiplied by BT, that is brightness temperature already calculated, and this is also constant value, again multiplied by emissivity, that actually we calculating here. So this is the last step, which is very simple. Okay, so click here. So last one is the raster calculator. Again click here. So according to our equation, so this is the BT minus 1. Okay, so we can, what we can do, we can directly copy this, or you can paste it here, and now we can modify. So BT means brightness temperature. Okay, so remove this and click double click here. So BT divided by 1, these all are the constant value. Again change it only, this BT means this brightness value, this is again constant, all of this constant, change this E equal to emissivity, and emissivity is the last one. So click here. So this is the formula. So if you write previously, then we can easily do this very clearly. Then click here. So now I will write here LST dot diff, because now I will do LST for this satellite image or for this area. Click on OK. It will take some time. So reduce all of this thing first. So now click here, go to properties, go to symbology. You can see here, this is the maximum temperature at 36 degrees Celsius and minimum temperature is 6.6 degrees Celsius. Okay, go here, select this one, apply and OK. This is the land surface temperature of this zoomed layer of this area. Now again what we can do, another thing, go to properties, go to classified, select this one. So here we can see the some classification or ranges. Now this image will show the some kind of precious result of LST, high as well as the lowest LST regions. Now I have a study area. So this is our study area. Okay, this is our study area. So click here, zoom to layer. So you have okay, this is my study area. So how can I extract my LST for my study area? So simple, within this special analysis tool, go to extraction. Here you can see extract by the mask layer. Okay, select LST, then input layer should be study. Okay, then output layer should be LST, right? You can write here LST study area, LST study area dot diff. So extension should be diff. Then click on save and go to environment, processing extend, then extend should be your study area. Okay, as well as go below raster analysis and mask layer should be your study. Okay, okay and okay. So close it previously, and now we can see only zoom to layer. Okay, again go to properties, go to classification, select this one. You may increase or decrease the classification number from here. Okay, 4, 5, 3, whatever you want. Okay, we can also take 6 also if you want. 5 is suitable for this. Okay, then OK, apply and OK. So now we can see the brightness, land surface temperature of the study area. Okay, so what we can do, just click here. So now this is in layout view, and we can assign the lat long and other thing. Okay, so go to here, go to properties, select grid, next, properties, interval should be 1 degree, I want to give 1 degree, level whatever. You can see my previous tutorial how to prepare study area map. Okay, here I just want to show just some basic. Okay, then you can write here zoom to layer. Okay, or you can reduce the grid also. Again, if you want to modify, then click properties, go properties, go to interval should be 3. Okay, apply, okay, apply. Okay, now it is quite good. Then go to insert, scale, legend, next. So this is legend. I will not modify now. You may see my previous tutorial, and there you can understand how to modify all of this thing. I just show you how to prepare this only. Then go to north line, select any one from here. So this one. Go to insert, go to select scale, select any one from here, go to properties, 2, click here, below center you can give, and the division should be kilometer, apply and OK you can give. OK, so scale will come, increase the front of the scale. Okay, now it is visible. So last one is the heading. So we can write here LST calculation of the study area. Okay, using Landsat 9. Okay, then select this one, go here, select this one first, go select value. What you can do, we can divide into 2 parts. LST calculation of the study area using Landsat 9 satellite. Using Landsat 9 it's okay. Then click here, okay, and we can also increase in some extent this one, and we can also change the color. Okay, if you want to change the color, we can change color from here. Okay, this is red. So 36 we can take 30. This is 30. Okay, then save it. So thank you for watching my tutorial. Keep subscribe my channel for more video and more update. Thank you again.